This lesson is going to be on factoring binomials. On the bottom of the sheet that we had from last week on our factoring strategies, the last category is binomials. And we're going to look at three different things today. The first is going to be the factoring the difference of squares. And then we're going to look at factoring the sum or difference of cubes. One thing that may help you prepare for this part, in your book on page 376, problem number 1 suggests that you write out the squares of the numbers from 1 to 20. That would help you recognize which numbers are perfect squares. Then on page 378, problem number 73 encourages you to write out the cubes for the numbers from 1 to 10. That would help you recognize which numbers are perfect cubes. If you know your squares and your cubes, then that's okay, but having that list in front of you might help you recognize numbers. So first we're going to look at factoring the difference of squares. And what this means is that we have two terms, binomial. They are a difference, meaning it's subtraction, and they are both perfect squares. As an example, suppose you had x squared minus 36. You would factor that as x plus 6, x minus 6. The two square roots, one's a sum and one's a difference. So what you want to write on your factoring strategy paper is that a squared minus b squared is equal to a plus b times a minus b. That is, when you factor the difference of squares, it's the sum of the two square roots and the difference of the two square roots. Now I'm looking at page 377, problem number 9. Those are perfect squares. This is 12 squared. It is a difference, so I can factor it as the sum and the difference of the two square roots. Now I'm looking at problem number 19. Just like we said before with factoring, the first thing you must always do is to look for the greatest common factor. And even though these are perfect squares, you've got to factor out the greatest common factor first. And the largest number that will divide into 36 and 16 is 4. So you factor that out first. Then what you have left is still perfect squares, and it is still a difference. So you continue factoring, keeping the 4 as the sum and the difference of the two square roots. Now let's look at problem number 13. Even though this is a binomial and they are perfect squares, this is 8 squared, this is not a difference. When it's a sum, it's prime. It cannot be factored. There's nothing that you could put in these parentheses such that you could multiply them and end up with this. There's no way. It won't work. So if that's a sum, you either write prime or it cannot be factored. All right, let's do one more. two terms. They are both perfect squares. It is a difference. And there's no greatest common factor other than 1. So I'm ready to do the 2 square roots. The square root of 16r squared is 4r. And the square root of 25a squared is 5a. And you make one the sum and one the difference. And it doesn't really matter which order you do it. Just one has to be a difference and one has to be a sum. If you want to put the minus there and the plus there, that's fine. Alright, so that's the strategy that we will use when it's the difference of squares. Now we're going to look at factoring the sum and difference of cubes. And I'm going to give you the pattern first. A cubed plus b cubed. That is, you have two terms. They're both perfect cubes and it's a sum. It's a plus b, a squared minus ab plus b squared. That's the pattern that we'll use. So I'm going to look at on page 378, and I'm going to look at problem number 81. It is two terms. It is a sum, and they are both cubes. The cube root of m cubed is m, and the cube root of 8 is 2. So you start off with the two cube roots, and you follow the sum. Then the next one says to square a, which is your first term right here. So this is m, so I'm going to square that. The next part of the pattern says subtract a times b. Well, this is my a and this is my b. So a times b would be 2m, and I put minus 2m. The last part of the pattern is to square the last term. So that's our 2. So we square that and you get 4. Now, you will not ever be able to factor this trinomial anymore. That'll be the final answer. All right, let's look at number 91. When you first look at this, it does not look like the sum of cubes because 6 is not a perfect cube. However, remember, the first thing we must always do is look for the greatest common factor. And so that would be 6. So I factor that out. Now they are cubes because this is p cubed and this is 1 cubed. So I keep my 6. And I do the sum of the two cube roots. Then you square the first one, you multiply them together, and you square the last one. And this one sign is going to, if this is a plus, that's going to be a minus. That one's going to always be a plus. All right, let's do one more. Alright, so the first thing I do is to look for the greatest common factor, and there is not one for 125 and 8. So I'm going to do the two cube roots. The cube root of 125 is 5 and m, and the cube root of 8 is 2. Then the pattern says square it, multiply them together, square. Square the first one. So 5m times 5m is 25m squared. The middle term is the product of the two. These two multiplied together. So that will be 10 MP. And the last term is the square of this one. So 2p times 2p is 4p. This is a minus. This is a plus. So that's factoring the sum of cubes. Now we're going to look at the difference of cubes. That pattern has the same kind of factors. It's just the signs are different. When you do the difference of cubes, you start here with the minus, and this one's a plus. So you'll notice it's opposites. If this is plus, this is minus. If this is minus, this is plus. And both of these last terms are always positive. All right, so I'm going to look at problem number 83. The two cube roots are y and 6. If this is minus, this is minus. Then I square the first one, I multiply them together, and I square the last one. This is minus, this is plus, this is always plus. All right, let's do number 88. These are perfect cubes. That's 4 cubed, and that's 3 cubed. So I do the 2 cube roots, 4y and 3. If this is minus, this is minus. Then I square the first one, I multiply them together, and I square the last one. If this is minus, this is plus. This is always plus. So there's my factoring. And remember I said you won't ever be able to factor that trinomial any additional amounts. You do still have to look for a common factor. I'm looking over the problems in your group, and I don't see any that do have... Oh, yes, I do. Yes, I do. Number 93. Oh, we'd already done one up there, number 91. All right, the greatest common factor here is 5, so you got to factor that out first. Then it is perfect cubes. This is a sum. So you keep the 5. You do the 2 cube roots. If that's plus, that's plus. Then you square the first one. You multiply them together. And you square the last one. If that's plus, that's minus. This one's always a plus. And so that would be the factorization for this. So now you should be ready to do the homework for 5.4 Part 1. I'll see you again soon.